to the new EXP coding space and the differences between it and Robot C. Now the main difference is obviously it looks a whole lot newer and fresher, but there's some other differences as well. For example, this coding space is actually going to be using like real C++, real C programming language. And that programming language is a little bit different than what we've been used to when we've been coding in Robot C. There's also a couple of nice features, I think, especially when it comes to writing the code and also with setting up the motors and other sensors that you might have when you are building your robot. So I'll show you those now. The first thing that we would want to do when we open up a file is to make sure that we set up our cortex or our brain. In this case, we're going to call it a brain from now on, so the EXP brain. And the inputs, or the things that you have plugged in, are accessed with this little button up here. Looks like an RJ45 button. Anyway, so if you wanted to add a device, you just click add a device and it gives you all the options that you can add. You know, you can add a drive train with 2 motors, which could be something very useful. And there's a whole bunch of functions that are set up for a drivetrain with 2 motors. A motor group, for example, if you have a couple of motors that are doing one task, for example, moving around and opening and closing a claw, or just a straight motor. All right. Also within the brain, there's an inertial sensor, which is pretty cool. And a couple of other sensors that we can get used to. But for now, we'll just go with our motors. And I've already got 2 set up, motor R and motor L, just like we would with the cortexes, okay? And I'm going to give this example as if I'm going to program the run forward function for a cortex, but I'm going to be doing it with the EXP. All right, so the layout of our coding space here is exactly the same as what, get this out of the way. It's exactly the same as what we have with Robot C. Namely that we have a main task. It's a little bit different though, and I'll talk about that in a second. And we do have our pragma file up here, but it is collapsed. You'll notice that we jump from line 1 to line 38, and that's because if you press this little plus button, it expands the setup of this program, and that setup takes up quite a few lines. But maybe if you look at the bottom here, you'll see that there's our familiar motors where we've got them named and it describes which port they're plugged into, which is pretty cool. So you can click the little minus, get rid of that. There's 2 other things on here that you might notice that we've got include Vex Library and using namespace Vex. And this Vex Library is all of these functions over here on the left side. This is the Vex Library. These are all pre-built functions that you can use for your robot. And using namespace Vex just says that we're going to, use a naming convention that allows this library to be used without having it conflict with another library, or the standard C++ library. Basically, don't worry about it, I guess. Okay, so let's say we want to build a function that is going to make our squarebot run forward. We'll start without giving it parameters, and then we will give it parameters once we've kind of got the function built. And it's going to follow the same pattern that we've used before, namely that we need to give our function a header, which is going to be void, and then we have to name it, and I'm going to call it run forward. And I'm not going to give it any parameters to begin with, so just open and closing parentheses, and you notice that as soon as I type the opening parentheses, there automatically puts a closing parentheses there, which is kind of nice. So if I want to, for example, put something in there, the closing parentheses already exists and contains whatever I write. If I don't want to put anything in there, I can just press or type in the closing parentheses, and that will, move my cursor over. Of course, you could just press that, move the cursor over one, and then put in whatever you want to put after it, which is fine. But that's kind of nice. The other nice thing is it does the same thing with curly braces. You type in 1, it automatically inserts a second one after your cursor. So then you can just click the enter button and it will automatically give you the opening and closing curly brace. It makes it a lot easier to not forget to have them, which is great. All right, so let's build this function. Now, we need to put in two start motor commands, one for each motor, the motor R and motor L. But it's different here. Instead of putting start motor and then in parentheses the motor name and the speed that we want it to go to, we actually put the motor name first. So we would type in motor R, and as soon as I start typing in motor R, it's going to show this little thing here, which gives me a list of all the things that are plugged in. I'm going to put in motor R and then you press dot, and we're going to do set velocity. Now, the set velocity is going to be most similar to start motor that we've been using, in that it gives us the opportunity to input the motor speed that we want it to go at. After all, velocity is speed with a direction, and in this case, the positive or negative sign gives us that direction. Now, the added thing in here is that we have a units option, and the units can either be in a percentage or in RPMs. Now, obviously, a percentage is going to go from 0 to 100. RPMs go from 0 to 127, just like our robots. So to keep things familiar, I'm going to set the RPM at 127, and then after that, my units then have to be RPM. Okay. Now I do the same for the other motor. And you'll notice that as I start typing, I can just arrow up and down on my keyboard and then click enter, and it will automatically finish that function for me, so I can type it in a little bit faster. So just type in R, click enter. All right, so there you go. I've started both my right and my left motor. Now I need a wait command, and you notice when I start typing in wait, it gives me two options, the wait with time in units or wait until. And we're going to use the wait and time in units. And in this case, we have an option to use a lot of different units like seconds, milliseconds, picoseconds, hours, minutes, whatever. In this case, we want to probably use seconds. So I'm going to type in like 5 and then type in seconds, and I can just click enter to finish it off. And then we want to stop both motors. And it's the same pattern as before. We would do motor R, stop. Very simple. Motor L, stop. All right, so there is a function with no parameters. Now let's add some parameters to it. The nice thing about this is that the parameters are added exactly the same way as we've been doing them before. Namely, I just have to make sure I declare what type of parameter it's going to be. In this case, it'll be integer. I need to name it. And remember that if I'm declaring a parameter, this is really a variable, but it's only used within this function. So I can rename this speed variable in a different function, but I don't want to make a global variable that can be used by any function and name it speed as well, because that'll make things get really messed up. So I'm just keeping my variable name simple, or my parameter variable name simple, and I'm going to call it int speed and int time. Okay, there we go. And for 127, I'm going to input speed. Down here it's going to be speed, and then over here it's going to be time. All right, so there's my function. All right, I've defined it down here. Now I just need to copy and paste the header from the bottom up to where I need to declare variables, finish it off with a semicolon. Now within taskmain, you'll notice that it is called int main, and that's really a C++, like a real coding thing, in that the main is the thing that is actually executed. Everything that exists outside of main is sort of help or setup for main. And you'll notice that main is a function, and it's a type integer, so it actually does return a value. Now I'm not going to get too much into that. It's just in robot C we call it, quote, taskmain, and the real is int main. But we probably want to put in an infinite while loop in here, so let's do that. Really, really helpful opening and closing curly braces, and now I can call my function run forward. Give it a couple of parameters, and there you go.